Hey, in this case, we're going to talk about factoring special types of polynomials. We'll call them special cases, and there's two special cases that we're going to discuss. The first one is if we have a trinomial that happens to be a perfect square. So what we're going to do is we're going to examine A, and we're going to examine C. And we can see that 9 and 4 are both perfect squares. So the way we can factor this is kind of simply, we'll start with our two parentheses, and the beginning of each parentheses is going to be the square root of 9, which is 3, and then that gets a g. And then the second is the square root of that number at the end, which is 2. And another way we can write this, since 3g plus 2 and 3g plus 2 are multiplied and are the same thing, is 3g plus 2 squared. So again, A and C were both perfect squares, so we can write our factors as the square root of A times g plus the square root of C. Then we can simplify it to be that binomial squared. Let's go ahead, pause, try these three, and you might have guessed it that they are perfect square trinomials. So this first one, the leading coefficient is 1, which is a perfect square, and the n, c, is 64, which is a perfect square. So we do the square root of 1, which is 1 times n, the square root of 64, which is 8. So those are our two factors. And of course, we can write that as n plus 8 squared. Number 2, because we end up with a minus sign there, we're going to end up with 3g minus 2 times 3g minus 2. Remember, a way to check your answer is to go back and multiply those two factors together and make sure you get the same answer, or the same polynomial started with. If these were pluses, you'd have a plus 12 there. So in order to account for that, we make these minuses. So we can say 3g minus 2 squared. Last but not least, to get 2t plus 9 times 2t plus 9, which is 2t plus 9 squared. And once you get comfortable with this, you can go straight to the final product where things are squared. You can go straight to that right away. Now this is the tricky case, because if you want to distribute and check your answer, it might be easier if you just have the two factors like we started with. Another type of special case is the difference of two squares. So here we have only two terms, but you might be able to see that 4 and 121 are perfect squares. So in this case, we're going to have two sets of parentheses again, and we're going to start with a, the square root of a, so the square root of 4, which is 2, with an x in both. In the difference of two squares, one is going to get a plus, one is going to get a minus, and then the square root of 121 is 11. So being that this is the difference of two squares, there's always going to be a minus sign in there for this case to work. So we're always going to end up with factors, one that's a plus, one that's a minus, everything else is the same. And again, the 4 square rooted gives us the 2, And the 121 square rooted gives us the 11. So again, pause, give these three a shot. Number 1, our squares are 1 and 36, so we end up with 1x plus 6, 1x minus 6. Number 2, our squares are 25 and 64, so we have 5x plus 8, 5x minus 8. And it's worth pointing out that it doesn't matter which order you put these two parentheses in. If you said 5x minus 8 first, that's totally fine. Last but not least, 10 and 40 are not perfect squares. But we have been factoring out greatest common factors. So if we can always factor out a greatest common factor. These both have 10 in common, so I'll factor out a 10. Now if you notice, we have a 1 here and a 4 here, so we can actually continue factoring to get x plus 2, x minus 2. Now that one was a little tricky. We hadn't thrown in there any problems where you had to take a greatest common factor out. But if you see a binomial, so two terms with a minus sign, and you're thinking this has to be difference of squares, but a, the number in front of x squared is not a perfect square, and this c is not a perfect square, then you might try factoring out a greatest common factor. And in this case, if you did that, you would see that x squared minus 4 is a difference of squares. So we can continue factoring. And now we have 3 factors of 10x squared minus 40. So go ahead and try these two. Try these 2 U tries. And if you have any questions, write them down. And we can discuss them in class.